So what you have is a woman is deciding to have children until she gets her first girl, or until she has 4 children. And they're quite nice to you because they actually tell you all the things that could happen. See, that one would be her first child was a girl, and that's it. I had my family, I've stopped. It could be a boy first, and then she gets a girl, so that's when she would stop. It could be a boy, 2 boys, and then the third child she got a girl. Or it could be until the 4th child was a girl. Or she could just be unlucky, like my sister Morag, who always wanted a girl, and she actually did end up having 4 boys. So go figure. So, for each one of these events, we are now going to find the probability of them happening. Now, at the top there, somewhere, they tell you the probability of getting a girl is 0.5. So, the chance that the first child is a girl is 0.5. That's the answer to that one, right? Now, what's the chance that you have a boy and then a girl? Well, if you want to find the probability of getting a boy followed by a girl, we consider these independent events. In other words, whatever you have in your first child has no effect on your second. And what that gets me is probability of a boy times the probability of a girl. These are independent events, so we can just multiply their probabilities together. And so we get 2 0.5s, and that gives me 0.25. Can you see how these are getting created now? Right. Yes. Now, if I go to this one, I'm going to skip a whole load of stuff. It's going to be 0.5 times 0.5 times 0.5, right? And the short way of writing that down in math is to write a little cube on it. So I'll go 0.5 to the power of 3, and we get 0.125. This one here ends up being 0.5 times another times a third times a fourth, so you get that. And 0.5 to the power of 4 ends up being 0.0625. And then lastly, you get 4 boys. And 4 boys is a boy times a boy times a boy times a boy, so it ends up being the same as that one. The probability of that happening is also 0.0625. So this has got the chapter 8, question 7, I guess, A part done, right?
Yes.
Now the part B has a table. It's called a probability distribution table. And what you do in these tables is typically on the top row, you write down all the things that could happen. And then on the second row, the probability of it happening. Now, they describe it in a funny kind of way. They call this guy K, and they call this probability X equals K. And in the storyline, K represents the number of, what would that?
Number of kids.
Well, not necessarily so much the number of kids, but let me check that. What one is that? 45.2. There's one missing here. Very interesting. Find the probability distribution function for X. And X is the number of children she has. I take it back, you are correct. So X equals K, so in other words, saying she had 1 kid, 2 kids, 3 kids. So she could have 1 kid, 2 kids, 3 kids, and 4 kids. That makes sense now. When K represents number of children she has. Well, let's find the probability then that she has 1 child. Well, out of these events, and there's 5 of them that we've already calculated the probabilities for, isn't that one the only one where there's 1 child in the family? Everybody else has got 2, 3, or whatever. So 1 child in the family, 0.5. 2 children in the family, and it happens here, 0.25. 3 children in the family happens only once, this guy. And then I have to be a little bit more careful. 4 children in the family can actually happen in 2 different ways. It could happen because you had 3 boys, and then you finish with a girl, but it could have happened if you had 4 boys. And when you have 2 events combined like this, you add their probabilities, and that guy plus that guy gets you 0.125. And we have finished question 7.
Okay, wait. You add which 2 together?
These 2 here, 4 children and 4 children.
Oh.
See, they're not asking you how many girls, they're not asking you how many boys, they're asking you, in this case at least, how many children. Now, you may have a different question, Tara. They may have asked you
I
in
had
your
it the
question.
opposite. I had it boys, but I was able to
Right,
figure
see?
it out.
Right.
then.
So, you know, depends on what you're counting. In this case, we're counting number of children, but you could have been counting number of girls. Well, not number of girls, but yeah, you could, I guess, but more likely number of boys.
I have a
Are we
question
good?
about the
Yes, Chris?
decimal on the
Yes.
last one.
That
When
one?
I add them to it, the decimal.
Yeah. When you add
'Cause-
these 2 together,
Yeah,
you should get 0.125.